Ever wonder how your car's engine just works? How it can be a powerhouse on the highway but still be efficient when you're stuck in traffic? Well, a huge piece of that puzzle comes down to one tiny, unsung hero. Today, we're pulling back the curtain on the mass airflow sensor, or MAF sensor. It's the little device that helps your engine breathe just right. So, let's start with a basic question. We all know engines need air and fuel to make power, right? But how does the engine's computer, its brain, know the perfect amount of fuel to squirt in there at any given second? It all comes down to knowing exactly how much air it's gulping down. And that, my friends, is where this brilliant little piece of tech comes into play.
All right, so let's get to know this unsung hero a little better. This sensor is absolutely key to making sure your engine gets that perfect air-fuel mixture, no matter what you're doing, whether you're crawling along in traffic or putting the pedal to the floor.
Okay, think of the MAF sensor as a critical part of your engine's respiratory system. Its one job is to constantly measure the mass, and that word is important, the mass of the air the engine is breathing in. It then zaps that information over to the engine's brain, the engine control unit, or ECU. The ECU takes that data and goes, okay, got it, and then calculates the exact amount of fuel needed for a perfect, clean, efficient burn.
And I can't stress this enough. The key word here is mass. You might be thinking, why not just measure the volume of air? Isn't that easier? Well, here's the thing. Air density changes all the time. A lung full of cold, dense mountain air has way more oxygen in it than a lung full of hot, thin air down at sea level. So by measuring the actual mass, the MAF sensor gives the ECU a much more accurate picture of how much oxygen is actually available. This little detail is a huge reason modern engines are so incredibly efficient.
So how does this little gadget pull off such a critical measurement without a single moving part? Well, the most common type of MAF sensor today uses this surprisingly elegant principle that's all about heat and airflow. It's really clever.
It basically all comes down to these 4 steps. First, there's a tiny little platinum wire or film inside that's heated up to a very specific temperature, let's say about 100 degrees Celsius hotter than the air coming in. Now, as you step on the gas, air rushes past this little element and cools it down. The sensor's circuitry instantly sees this and says nope, and cranks up the electrical current to bring that wire right back to its target temperature. And here's the magic trick. The amount of electricity needed to keep that wire hot is measured. That measurement is directly related to the mass of the air flowing by. That data then gets sent off to the ECU.
It really just boils down to the simple, beautiful relationship. The more air that flows past, the more it cools the wire, and the more electrical current is needed to heat it back up. The ECU can read that change in current and know exactly how much air the engine is getting. It's a genius system, and again, no moving parts to wear out.
Okay, so now that we know how it works, let's do a little dissection. What are the key bits and pieces of the sensor itself, and where would you even find this thing under the hood?
A modern MAF sensor has just a few key parts. You've got the protective plastic housing, then the really delicate part, the sensing element, which is that hot wire or film we talked about. You've got the control circuit that does all the heavy lifting, an electrical plug to talk to the ECU, and most of them now have an intake air temperature sensor built right in for even more accuracy. Oh, and you'll often see this little honeycomb screen on the front. That's not for measuring anything. It's just there to straighten out any choppy, turbulent air so the sensor gets a nice, smooth flow for an accurate reading.
And where does it live? Well, if you pop the hood, you'll find it tucked into that big plastic tube that runs from your car's air filter box toward the engine. Its location is super important. It has to be able to measure all the air going into the engine, but only after that air has been cleaned by the filter.
But you know, these sensors haven't always been these sleek, sophisticated little gadgets. Their evolution is actually a pretty cool story of how far automotive tech has come.
Back in the 70s and 80s, cars used these big, heavy, mechanical things called vane airflow meters. Then, in the late 80s, Bosch came along and totally changed the game with a hot film technology and a much lighter plastic body. The next big jump was in 2002, when the signal it sent to the ECU went from an old-school analog signal to a digital one, which is way faster and more reliable. And today, the newest sensors can even measure the humidity of the air for the ultimate level of precision.
I mean, the difference between the old tech and the new stuff is just night and day. The old meters had a physical flap that the air had to push open. That's a moving part that can wear out, and it literally got in the way of the air, choking off potential power. Compare that to today's sensor. No moving parts, almost zero restriction, way more accurate, and it weighs a tiny fraction of the old ones.
We're talking less than 300 grams compared to over a kilogram. It's a huge difference.
So where does this technology go from here? As you can probably guess, as our cars get smarter, so do their sensors.
The physical design is just going to keep getting smaller and better. We're looking at things like micro-electromechanical systems, MEMS, which will make these sensors incredibly tiny, tough, and even faster. And a faster response time is a really big deal for accurately measuring the pulsating airflow in modern engines, which means even better fuel efficiency for you and me.
But here's where it gets really cool. Connectivity. Imagine your little MAF sensor being part of the Internet of Things, constantly beaming real-time data up to the cloud. This could let a technician diagnose a problem from miles away. Or even better, imagine an AI analyzing that data and sending an alert to your phone saying, hey, your sensor's getting a little dirty and your fuel economy might drop soon. That's predictive maintenance, and it's right around the corner.
And this quote really gets to the heart of why this technology is so important and isn't going anywhere. As long as we have combustion engines on the road, the push for cleaner emissions and better fuel economy is relentless. And that means the job of the humble MAF sensor is only going to get more and more critical.
So when you step back and look at it, the journey of this one little component is pretty amazing. It's gone from being a big, clunky mechanical gatekeeper to a super sophisticated digital nerve ending for the engine. It's truly a cornerstone of the performance and efficiency we've all come to expect from our cars.
And that kind of leaves us with a final thought to chew on. We've seen how this one sensor has become a tiny, smart device. It really makes you wonder, as cars keep turning into computers on wheels, what other simple little sensors are quietly evolving to become the real brains of the whole operation? Something to think about.